Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn all about asynchronous programming. Specifically, we're going to learn how to use the async and await keywords in C#, as well as how to use the task type. Okay, so first of all, what exactly is asynchronous programming? This is how we can have code that executes in a non-linear sequence. Basically, it's how we can have some code pending for execution while some other code is executing. One great example is simply to think about cooking. For example, let's say we want to cook some breakfast. We want some coffee, eggs, bacon, toast, and so on. Now, if we do it in a non-asynchronous manner, meaning if we do it all sequentially one task after another, then first we pour some coffee, after that's done, we heat the pan, after that's done, we fry some eggs, then afterwards do this, and so on. So basically we do each task to completion one by one until the end. So in total with this, we would spend maybe 30 minutes. But obviously, in looking at this example, you can probably see that this doesn't really make much sense. You wouldn't really make your breakfast this way. There's no point in standing around doing nothing while the pan is being heated. You can start some of these tasks at the same time. So the asynchronous method of doing a breakfast is like this. So we pour some coffee, and then we start frying the eggs, start frying the bacon, and start toasting some bread. We start these three tasks at the exact same time. Then while those tasks are making some kind of progress, we continue doing anything else. As soon as the task complete, we get notified and we can do more things. So for example, the eggs get done while bacon is still cooking. Then the bacon is done while the toast is ready, so we start putting some jam and so on. So basically we start a bunch of tasks, and then in the background we wait for them to complete, and while we're waiting we can do other tasks. So in total, by using this method, naturally we would make it quite a bit faster. Although here, let me point out one extremely important detail. Asynchronous does not mean multi-thread, meaning everything, all of it, still runs just on one thread. Making something asynchronous just means there's really a pending task and we're waiting for it to complete. So the common example in actual code is doing something like contacting a web server. We make the request, and then we just sit around and wait for that request to return, for the server to actually send a response. Meaning our CPU is not actually doing any extra work on that task. It sends out the request and just waits for it to complete. So always keep that in mind. Making our programs asynchronous helps us keep the program nice and smooth without freezing, but it does not make it multi-thread. Okay, so now that we've seen the theory behind async programming, let's learn the syntax in C#. So for example, let's say we have a function to contact a web server. So up here, let's make a void contact web server. And now here we do something that takes some time. So we would make some kind of HTTP request. In order to simulate this, let's use the task.delay. This function basically waits a bunch of time. It's simply going to delay execution. It's not actually going to do any work. It just waits. This one takes some milliseconds, so let's wait for 3 seconds. Okay, so here we're pretending to contact the web server and wait for a response. Let's just do a log here. So console, let's do a write line, and let's print out contacting server. So we're contacting, and then we contact. Then let's say by this, the server has finished getting a response. So let's say got a response. Okay, just like this, and for testing, let's run this. Although this one actually quite worked, but let's test. And if that said, just basically ran both of them at the exact same time. So it didn't actually wait any time. That's because over here, task.delay, note how this one says awaitable and returns a task. So this is an asynchronous function. This task object itself, this is what contains the data for the pending action. If we want to wait until this action completes, then we need to await it. So right before it, we write the keyword await. Yep, just like this. This will basically pause the execution right here on this line until this task ends. And when the task ends, then it continues going on to the next line. Again, remember, this does not make it multi-thread. When we use await, this logic for the task.delay, that one is still going to run on the main thread. It is simply just going to wait until it is completed before continuing. And also here we do see an error. It is telling us the await operator can only be used within an async method. So in order to make this work, we need to mark this function as async. Yep, just like this. So now let's test like this, except it also didn't quite work. We can see it did start contacting the server, but the program just ended before we got a response. So let's make sure we keep our program alive. We keep it running while we wait. So for that, we can just do a while true, just an infinite loop, just so it keeps running forever. Then we can forcefully close it. So like this, if we test, okay, there it is, and contact the server right away. And now after 3 seconds, yep, there you go, we've got our response. All right, awesome, so this worked. Here we have the main asynchronous syntax. We mark our function as async, and then inside it, when doing some kind of asynchronous work, whenever we want to wait for something to complete, we use the keyword await, and doing so basically it will pause the execution of this function right here, and will only continue after this task completes. However, very importantly, note how up here it did not pause. So down here on this function, when we got to this, it paused and waited for 3 seconds before it ran this line, but up here, we ran this line of code right away, and we went inside the while true immediately. We can actually put a console.log over here just to see exactly, and let's see. And if there it is, it's constantly printing out dashes, so that code is running. This is very important. So we ran this line of code, which in turn started this action and then waited for it to complete. But whilst waiting for this one, the code over here on the main function, that one continued executing. So it did not stop on this function, it continued going on to this one and continued going on forever. So with that, we had two branches of code running at the same time, except they were not really running at the same time. Again, this is not multi-thread, we have just a single thread. What we had was essentially two pending tasks. So whilst working on the main thread, our code was constantly testing, is this task done? Just doing a quick check, and if not, then just continue running the same code as normal. And then when this task completed, then continue going on to this, it finished this function execution, and everything else ran the same. However, also one very important thing, which is how up here, like we saw, the code does not stop. So we start contacting the web server and then we continue running some logic. So if we do this, if over here our code does not stop, how exactly can we know when our task has been completed? So in this example, how exactly do we know in here when have we finished contacting the server? When can we actually get some data back? So let's say we get some data. So let's just define a string for the server return data. So you have this, and over here after we contact the server, let's get some data back. Okay. So now the question is, how do we know over here in this code, well, inside of this while, how do we know that this data has been returned? If we just try reading it right away, so let's get some int for some kind of data length. Let's just access the server return data and get the length, just trying to access that object. If we do this, naturally it won't work since the data will not be set right away. It has to actually wait for the server. So if we test this, yep, obviously we get a null reference exception. The data has not yet been returned, so this one is still just defaulting to null. So essentially we need to know when is this task done executing. And for that, we can use the same task type ourselves. So over here on this function, instead of returning void, let's make it return a task. And up here when calling it, let's grab our task. And then inside of this one, we can access all kinds of things. So here we can get a bunch of stuff. And the main one is really over here, these properties. So like is completed. This one is going to be true when the task actually completes. So let's just check for this one. So if the task is completed, if so, then let's get the data length. Let's just do a print on that. Yep, so now while the task has not been completed, this code is not going to run. And when it does complete, then we have our server return data, and now we can run this logic. Also, by the way, alternatively, we could just call task.wait. This one would work, but this would block our main thread. So our code would not keep executing like this. It would stop right here until the task actually completes. Whereas like this while is going to constantly running over and over again until the task completes, and then it's finally going to run this logic. So let's test. And up here we are contacting server, and after a while we should be able to see, yep, there you go, we've got our length. Okay, great. So here we can see that our function waited until we were finally able to read some data. However, usually you actually don't want to use this method, the method of doing a while true and then waiting for the task completed. Usually the proper way is exactly like we did it down here with the task.delay, meaning we should use the await keyword. Like we saw here, that won't pause the execution of the rest of the function until it completes. So over here, instead of grabbing the task manually and then manually waiting for it to complete, instead of that, let's just await this function call, just like this. And then any code after here, we can assume this function has been finished, which in turn means we do have our return data. So we can get rid of these checks, we don't need them. Just like this, it won't work. So it starts contacting the server and only continues running this code after the server has returned a response. However, again, when you use awake, we need to mark this as async, so we have to do it like this. But if we try this, if we try making main async, if there it is, we actually have an error. And the error is telling us program does not contain a static main method suitable for an entry point. So making this function signature async void main, this is not valid for a main function. However, we can definitely make main into async. We just need to make sure that for the type, instead of void, we return task. And if like this, it should work, so let's test. So here we are contacting the server, and we are indeed waiting. And after 3 seconds, yep, we get a response, we get the 4, and everything works perfect. So yep, just like this, it worked. We did not have any errors, because again, the program stayed on this line. It did not continue down until this function was completed. Then when this one is completed, then down here, we can make the assumption this has been set, because we do know this task has completed successfully. So now that we've seen this syntax, let's actually see that breakfast example. So for example, we have our functions to do all kinds of things. So let's do a static async, let's return task, say like cook eggs. And in here, let's do a console.writeLine in order to say that we are starting cooking our eggs. Then let's do the same thing. Let's pretend this is doing something. So let's use task.delay, just wait for a little bit. And let's say the eggs take 3 seconds. Then a console.writeLine saying that our eggs are done. Okay, great, like this. Let's make 2 more. So let's make one for cooking bacon. And for bacon, let's say it takes a bit longer, so it takes 4 seconds. And then finally, let's make toast. And this one is quite a bit faster, let's say 1. Okay, great, just like this. So we have our breakfast functions. And now up here on our main, in order to start running those functions, let's first actually see the sequential non-asynchronous method. So let's first cook our eggs, but let's await it in order to make sure the eggs fully finish cooking. Then let's do the same thing, cook our bacon, and let's also await for it to finish. And same thing for make toast, let's also await for it to finish. So this is essentially going to be our synchronous method, meaning we're going to fully cook the eggs, then fully cook the bacon, and then fully make the toast. So let's see this. And okay, there it is. Eggs are starting to cook. And after a while, eggs are done. Now starting to cook some bacon. And after a while, bacon is done, starting to make toast, and toast is done. So yep, with this, we made our breakfast, but we also wasted a ton of time. We can essentially do all 3 of these tasks at once, assuming we have 2 pans. There's really no need to wait for the eggs to finish cooking before we start cooking bacon or before we start making toast. So instead of this synchronous code where we fully finish one task before starting another one, instead we can start them all at once, meaning they all start cooking right away, and then we just need to wait for all of them to be completed. So instead of waiting it, let's grab the task from that, so the eggs task, and over here task for the bacon task, and finally a task for the toast task. So we have all 3 of our tasks, and again this code is going to run sequentially right away. So we're going to immediately start cooking eggs, immediately cook bacon, immediately make toast. And then after starting all of these tasks, now we do want to wait for all of them to finish. So in order to basically await multiple tasks, we can use inside the task class, there's a when all function. This one takes an array of tasks. So let's wait for the eggs task, the bacon tasks, and the toast tasks. And yep, this one is going to be an awaitable call. So let's wait on this, which means the code is going to pause execution on this line until all 3 of these tasks are done. And then down here, we have our breakfast done. So console, let's write line, our breakfast is done. Okay, so yep, just like this, let's test and see. And if right away we can see cooking eggs, bacon, and toast, all of that starts and toast ends right away, eggs done, and finally bacon done, and we have the full breakfast done. All right, awesome. So we got our breakfast done, and we made it much faster because we started all our tasks right away, and we just had to wait for them to complete. So instead of cooking each task individually, instead of that, we started them all, and then they all finished. So this is really how async works. You start doing some work, and then while waiting, you can go do other work. Now with all of this, there's really only one thing missing, which is how do we return data from one of these functions? Right now, this is just returning a task, meaning it's actually not returning anything, but we can indeed return some data. So on the test type, we have a generic version for exactly that purpose. Then over here, we use whatever type we want. So for the contacting web server, let's say we want to get a string back, just like this. So instead of setting some kind of field, let's just return our data. And yeah, just like this. So now here, the way that we call this is we call the function, but we want to wait for it to complete. So let's await it. And in order to get results, we really just put it over here. So server return data, just set it equals to that one. And now we can do a console.writeLine on this one. And since we awaited, it's going to pause in this one before going into this one. So this one should have the correct data received from the web server. So let's see. And okay, it's calling the server. It's waiting for a little bit. And after a while, yep, got a response, and response was indeed data. Okay, great. So this is how asynchronous programming works in C#. We have tasks. We can start those tasks right away. And then we can wait for all of them, which will essentially pause the code execution until those finish completing. And then it continues running the rest of the code. Then if we use await on some kind of function, we also need to mark it as async. And when using async, we can either return void, which usually doesn't make much sense. Usually you want to return whatever task you are waiting. So you usually want to return either task or the generic in order to return some more data. Now, like I said many times, and let me repeat once more, just because it's something a lot of people get confused about, asynchronous programming is not multi-threaded. All of this code right here, all of it is still running just on a single main thread. We're actually going to learn all about multi-threading in the next lecture. Alright, so that's asynchronous programming using async, await, and task in C#. It's how you can keep your program running and not freeze while waiting for some kind of external result to arrive. This is extremely important in order to make sure your applications stay nice and responsive.